Hi everyone, we've made it to question number 5. It is a two-parter, but the second part is a bonus part. I just want to be really clear that um, if a question like that shows up on your midterm, that is not going to be included in the main part of your score for your exam. It would probably show up as a bonus question rather than something for your main marks, okay? I'm going to do a completely separate video for that one because it is a bit lengthy and there's more to it. So we'll just do the first part, part A. Again, part B would be for bonus marks, okay? Okay, so let's get into the question. What do we have here? Well, we have a runner who sprints for at the end of the race to clinch a victory. Okay, they had an initial velocity of 5 meters per second and accelerated at a rate of 0.2 meters per second squared for 5.4 seconds towards the line. What is their final velocity, so VF, at the end of this acceleration period? So let's draw this out and see what we're doing. So we got a runner. We have some sort of point in time until this finish line. So we're talking about some sort of a period of racing here. And some point in time in there, what they have is they have an initial velocity of 5 meters per second. And they're accelerating. So what that means is every second that passes, they're increasing in 0.2 meters per second of velocity. So 1 second goes by, now they're going at 5.2 meters per second. Another second goes by, now they're at 5.4 meters per second, etc., and so forth. Okay, so that's acceleration, right? So acceleration is 0.2 meters per second squared. We spoke about how it's like meters per second in an earlier video. Okay, so what do we know? What do we not really know? Well, we know we're looking for VF ultimately. Okay, that's kind of the question that we're after. But what are some other things we don't know? Well, we don't really know at this point in time the displacement that occurs during this acceleration period. So at some point in time, after 5.4 seconds, so I guess we know time. Forgot about that one. That's good. So after that amount of time, we actually don't know where along this line the change in displacement is going to be. We don't really know that, right? We just know we start at some velocity, we accelerate, and then after a certain amount of time, we stop accelerating. It's kind of all we're being told here. So we don't know our displacement either, okay? We do know like there's a finish line somewhere here, and that they're racing towards it, okay? Okay. So let's go back now. Now that we've collected all our information, we know what we don't know, and we know what we know, and we know what we're looking for, most importantly. So at this point in time, this is when we look at our equations. So we go over to our kinematic or equation sheet. Intuitively, most of us by this point in time are looking and being like, okay, this is a straight line run. We have acceleration, displacement, velocity. All of these tell us about our kinematic equations. Let's go take a look there. Sure enough, we turn to these and we can start going through our checklist. What do we have? What are we looking for? What do we not have? So in this first equation, we see an initial and a final displacement. Sure, we could use that. I mean, it's information we don't have, but so sorry, but like we could use it if we wanted to know a change in displacement. We could move this x over here by minusing initial velocity from both sides. However, we don't have that information, and it's not our unknown we're looking for, right? So what this is telling us is we have two pieces of information that we don't know for this equation, so it's gone. We're going to get rid of it. Not going to use that one. Okay, so second equation. So we have an initial velocity here we have an acceleration, which we have, and we have time, which we have. And we're solving for velocity final. So, aha, that's the equation we're going to use, right? So we have one unknown and all the other information that we want, that we're provided. Okay, great. So let's write that down. So we got velocity, that's Vf equals V naught or V initial plus AT, right? Okay. So at this point in time, like I said, we've been given all that information, so we can just fill it in. It becomes a bit of a plug and play. So velocity initial is 5 meters per second. We're going to add that to whatever our acceleration is, which is 0.2 meters per second squared, which is multiplied by our time, which is 5.4 seconds. And then we just calculate that out. Okay, and that gives us our VF. So VF equals, let's see, 5 plus 2 times 0.4. I just carried it all the way through. Okay. So once you crunch that all out, what you get is 6.08, and because it's velocity, we know that it's meters per second. And again, on an exam, you just round up to one decimal place. So for now, so we got 6.1 meters per second. That's your answer. Okay, and that's it.